It's recording now.
Second.
Well played. Alright, let's see. I should be able to scroll this down. Let's find out. Alright, guys, so here we go. You guys have your maps out in front of you guys.
Wait. Did I put this in the right spot?
Yeah, because it'll disappear when you close it up. You're good. Okay. All right, you guys. So looking at this, yesterday we talked about valence electrons and shells over there. Okay. And we also, at the very end, we kind of dropped down here to your Bohr models, and we spent some time talking about why those work to connect. Okay. When they connect, they form bonds. So today we're going to spend most of our time in this last column. So you guys are way up here on the right. Okay. What I'm going to do for that is I'm going to zoom in because I got this zero, so I can do that now. Okay. And maybe I can move the screen over. Yeah. All right, cool. All right, so we're going to be working in this corner up here. All right, so we're going to talk a little bit about bonds today. All right. Bonds, atomic bonds. No, nobody?
I
Okay,
got
well,
it.
Dun, 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 dun. Okay, so there's kind of like types of bonds and kinds of bonds. These are not scientific terms, okay? I'm just talking about how people talk about it. So we're going to talk about some types of bonds. We're going to talk about some kinds of bonds today. And since they're not scientific terms, I'll use those terms interchangeably. But when we talk about types or kinds, we're going to talk about single. Okay, so we have single bonds. All right, so with single bonds, we're going to use an example of hydrogen. Okay, so we have hydrogen and hydrogen. And yesterday we were using Lewis dot structure. What does Lewis worry about? Valence electrons. And valence electrons again are in the outer shells. Okay, so hydrogen has how many valence electrons? One valence electron, right? There's one here and there's one here. Okay, so each of these has one. All right. Now it's a period one element. So how many electrons are in the outer shell? Two. Okay, if you forgot what we're talking about, open up your mouth, look at your bullseye. When you guys have the center of your bullseye, there should say electron shells. And then in shell one, you're going to see that there are 2 electrons. And that's because how many elements are in period 1? 2. Okay, so now looking at this, they want to be happy and they're going to share an electron each. That means they each have 2, even though they're just sharing. And we're going to end up writing it like this: H dash H. The dash represents a single bond. Okay, the dash represents a single bond. Okay, next one we're going to talk about is double bonds. Double bonds, and we're going to use oxygen as an example here, okay? And so we have oxygen, and if we do Lewis dot structure, we're going to go, oh, I'll do that every time. Okay, 1, 2, 3, 1, 2, 3, okay, here we go. And then we got this guy, oh, and we got this. Okay, before we jump too far ahead, how many electrons are on my Lewis dot structure? So there's 12, but how many on each one? 6. What's the atomic number of oxygen? 8. So why are there only 6 up there?
Because we're sharing it with 2.
Okay, so a period 2 element like oxygen has them in what shell? The second shell. And how many does the second shell want? 8. Okay, so we know they're going to share. So maybe this guy shares like this, and maybe this guy shares like this, and then this guy shares like this, and this guy shares like this. Okay? That's kind of a train wreck, right? So this is how we draw it. We do O. Oh. This is a double bond. How many bonds are there? 2. Crazy concept, right? Let's do something even more crazy. How about triple? A triple bond. Let's do nitrogen. Can someone tell me atomic number of nitrogen? 7. Okay. So is it a period 1 or a period 2 element?
2.
Period 2 element. So how many shells is it going to have? 2 shells. Okay, and then the first one's full. So how many electrons was that again? 2. So if its atomic number is 7, and we already used 2 electrons, it's going to have 5 left, right? So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have these guys. That's kind of weird, but here's what it looks like when we talk about the bond. Okay? Now, we would use Lewis dot structure when we want to talk about valence electrons, or we would call them free electrons. Okay, the electrons that are in the outer shell that want to trade out, they want to swap. Okay, but when we're talking about bonds, it's more effective for us to write it this way because we want to look at the bonds so we can figure things out. Now, there's some rules for bonds, okay? So we're going to put more food on the board.
Mr. Moore, I have a question.
Is it my obsession with fruit
No.
and shoes
Why?
And Legos?
and Legos? That is a real thing. We don't have time to discuss that obsession.
My strange addiction.
Okay, so ready, you guys? What is this thing?
A pineapple.
It's a pear, okay? So this, my friends, is a pear. But even though this is a pear, we're not worried about pears, we're worried about pairs. Now let's see, this is a P-E-I-R, no, P-A-I-R, P-A-I-R, and that pear represents this pair of shoes, but more importantly, it also represents this pair of electrons. Okay, so check it out. Let me explain. Let me explain you something. Okay, let's see. We're gonna write down that one bond equals 2. We're gonna draw an E with a little negative guy up here. Okay. What's that? E with a little negative sign. What is that?
Electron.
It's an electron. Okay, so you guys, one bond equals 2 electrons. Why? Because bonds come in pairs. Now, this gets weird because if we were working with this and we we're going to split this hydrogen and we're going to use it on other things, if you're not careful, you'll have 1 electron. And when you have 1 electron, you put it somewhere. Did you count for both the electrons? No, because there's 2 electrons in a bond. There's a pair. Okay, you guys get it? The pair is to help you remember. The pair of shoes is what it's really about. And then if you guys really wanted to get like morbid, we could kill our pair by pairing it.
Well, that's it.
Let's not do that. Let's not do that. Okay. P-A-R-E, P-A-I-R, P-E-A-R.
You got a pair of pairs.
Pair of pairs. A trifecta of pairs. The plural of pairs? Okay, we're gonna move on. Okay, so you understand this whole mess? 1 bond equals 2 electrons. Okay? Alright, cool. Now we're gonna slide down and we're gonna continue talking about bonds, and we're gonna move on from types to kinds. Sure, that's what we're gonna say. Okay. So the first one we're gonna talk about is ionic. And the cool thing is, I don't have to say much about ionic because we already talked about them yesterday. There were 2 kinds of ions I put up on the board, okay? The only good cat is a
Dead cat.
dead cat. And what was our dead cat's name?
Pause.
Pause. And why was his name Pause?
Pause.
And where does he live on the periodic table?
The left side.
On the left side with the metals, okay? That area, because they like to what electrons? Lose, give them away, okay? All right, so these happen to be ionic, okay? Ionic bonds, they like to give or take electrons, okay? They like to give or take. If they take electrons, what did I draw on the periodic table for that? An onion, an anion. Hey, it's anions, right?
Yeah.
Okay, and then what was up with the onions?
That
They
they're
have
negative.
layers.
They
wanna get
I don't know.
ogres.
No.
They're negative. They want to
Oh,
what?
okay.
And you don't want to go to McDonald's.
You don't want to go to McDonald's, get the onions on your burrito, or in your burrito. Yeah, don't get the burritos at McDonald's anyways.
Ew.
On your burger, that would be bad, right? So you guys,
Oh, no.
anions take electrons, which makes them negative, which makes them an ionic bond. Okay? So ionic bonds, they like to give or take electrons, and they also have a crystalline structure. Okay, crystal. They have a crystalline structure. And what that means is it's a repeated pattern, brick, 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 usually, okay? So when I draw a picture to represent this, I draw my different structures, okay? And you guys will find that this happens in nature, okay? And a lot of times it happens with salts, right? Okay, ionic structures, okay? What do you got?
What's the word under give or take?
Crystalline. They're like a crystal structure, crystalline structure, okay? So these are ionic bonds, and we have cations and anions. Okay? The next one we're going to talk about is covalent bonds. C-O-V-A-L-E-N-T. Covalent bonds. Okay? And we're going to break this word down real quick here. So we have C-O. What does co usually mean?
Pair.
Pair or collaborate or cooperate or corporation. These tend to be things that are a larger entity made of smaller things that work together, correct? And if only we had a definition somewhere for valence, huh? Wait, did we already write this word on our periodic table? Are you sure?
Where?
Valence, under your target. So wait up, what are we talking about here?
Valence electrons.
Valence electrons. Okay, valence electrons. So now we're talking about cooperating or pairing valence electrons. Hey, covalent means that they share. Okay, so covalent bonds. First of all, we're going to write down that they have a molecular shape. And then we're going to write down that they share. Okay? They share. Now, the weird thing about these guys is what's a molecular shape? Well, it's, I don't know, stackable like this, maybe, and then it goes like this, and then maybe it goes like this, and maybe it goes like this. Hey, that's a capital M. Anyways, okay, so molecular shapes tend to be maybe pyramid-based, okay, kind of deal, all right? And they tend to share, but we have to put a question mark behind share, because they share kind of funny. All right, you guys know that you've been put in charge of, like, all the siblings in the house, because you're the oldest, and then parents go out, and then you get on the game system, and you're just playing. And they want to turn, you're like, in a minute, when I clear this level, after my high score, go away, I hate you. These kind of comments, right? And then so you're playing, and then they start to cry and throw a fit, but you don't care because you're bigger than them. Even if they're kicking you, you're still winning on your game, so you don't care. And then you hear that crazy noise, the garage door opener. And so you hand them the remote, you get out your homework, and you sit down at the table. When mom and dad come in, there's your sibling crying, pouting, and playing, and they say, he's not sharing, and then you just say, oh, no, I'm doing my homework. Clearly I'm sharing. They're on the video game. And that's how life is. And those of you who are laughing are bad people, and you're the older sibling. The rest of you guys are like, that sucks. Right? And so you guys, that sharing, is it equal sharing or is it not fair sharing?
Not fair.
All right, I want you guys to slide down your screen.
So nice.
If you guys slide, sorry, no, I can't slide down the screen. Slide down your periodic table. I want you guys to look at your Bohr model for water. Look at your Bohr model for water. It's on the very bottom. Okay? I will show you where it is. I'm going to slide all the way down, and I'm going to slide all the way across.
Rich will go.
Where'd it go? Oh, it's not on this one because it's on the fold. All right, so your Bohr model, I'm just going to draw here. Don't draw this. Your Bohr model, you guys have this for O, and then you guys have like this for your H, and you have this for your H. And do you guys remember I had you guys put a plus sign right here?
Yes.
And I had you guys write a minus sign right here? Which one's the older sibling? Who's hogging the electron? Oxygen. Who doesn't get it? Hydrogen. And so if the electrons are usually here, this becomes what we call polar. Okay, so I'm going to erase this now because I don't want it in the way of our next thing. But I want to talk to you guys if we have spinning wheel of death. Okay, if we have, still kind of hanging out, sure. Okay, great. If we have water, which is a covalent bond, but it doesn't share equally, we call it covalent polar, or a polar covalent bond. Okay, and that means that it is sharing, but it's not sharing equally. Okay, all of the bonds that I wrote at the very top of the page, because they're the same elements, they share equally, because they equally want it. Okay, so they would not be polar. Does that make sense to you guys? Okay, all right, so the last one we got is we're going to have metallic bonds. Metallica. Okay, metallic bonds. These guys tend to be, you guessed it, metals. Okay, and it's weird, they freely share. Now, that's a weird concept because they just don't care. So let me tell you, like, metals are a little bit strong. So when I draw these guys, I usually draw an E in here, okay, and I have my circle around the E for the electron. And then I have another one here, this guy. And then you guys just have to bear with me on my poor drawing skills here. Like this guy here, and this guy here, this guy here. Okay. They're fairly strong bonds here, okay? And then they like hook up with each other. They kind of stack on each other. And I know the little elbow thing's weird, but if I draw without the elbow thing, it just doesn't look like one. Right? You guys are like, why do I draw these dumb things? Because you'll remember. Okay, so these electrons are incredibly strong and they're stacked, okay? Now when I say that these freely share, you literally have stacks and stacks of these atoms, and the electrons just float wherever they want to.
Oh, yeah.
They're all stuck together because of the electrons, but they're so sharey, they're like, oh, you can have it. Oh, you can take it. Go ahead. Let's keep it for a while. Okay? It's like when you live on a block where it's like a cul-de-sac, and then all the kids play in the middle of the streets in the cul-de-sac. Okay? Right? Like all the kids just go out there, no one cares. Okay? They're just all running around, and it's crazy. All right? It's really funny with metallic bonds because they do this. If they're able to come together as a big bunch of metals, and they come together in one long strip of metal, what do we use really thin, long strips of metal for?
Building.
Wire.
Wire. And what does wire do?
Conductor.
It conducts electricity. It's also malleable. That's part of the reason why it's malleable. Okay, but it conducts electricity. So electrons, because electrons are freely shared, we can put a battery on one end and on the other end, and electricity will run right through it. Okay, so it'll share all that stuff. You good to go, Matt? Okay, cool. It'll share those electrons, which is really cool. Now, what's funny is if you just take a bar of metal and you're able to line up the electrons, like by hitting with a hammer or something, and the electrons tend to hang out at one end and not at the other, what does that metal become?
It's not in here.
Usually becomes a magnet. Cool. All right, you guys. So these guys end up sharing, and they can become magnets as well. Okay. So we're almost done here. I got one more thing to show you guys. So if you guys look on my drawing doesn't fold. You guys can unfold yours, and you guys will lose this noble gas that's in the way because we're going to work in this little area here. Okay, so we're going to be working in this area down here, and we're going to do a couple of examples. Now, everything I've shown you today, they're all the same thing. We're just drawing them different ways because we use them for different things. So I'm going to show you guys a couple more structures. Okay, the first thing we're going to do is I'm going to show you guys what we call space fill model. Space fill. The second one that I'm going to show you guys is stick ball. Okay. And these are really amazing terms they name these because if I was going to do, let's make this blue because it's water. If I was going to do H2O, okay, it's water, all right? And so when we use this one, it's going to be space fill. We just do a circle here, some circles here. There's no space between them. And this is H, this is H, and this is O. This shows us the molecular structure of water, okay? But if we're going to do stick ball model, we have the O right here, and then we actually have these sticks pointing out to the other players. Now, this is really good to use when we do 3D models, okay?
I went to the next page and it took me out, but I went back
And everything's there?
Do anything.
So now you're stuck?
Yeah.
So hit the refresh button.
Is it clear?
No, it won't. Your other message that came up, it would wreck your life, but this one, just refresh, you'll be fine. Okay? All right, you guys, so this is your stick ball one, okay? Now we're gonna do a different one. We're gonna do salt. Okay, so we're gonna do salt. Should I change colors? What color should my salt be? Red.
White. Oh, yes.
White doesn't work. This is salt. Okay, so for salt we have NaCl, and it's space fill, so they just touch. Once again, it shows us stuff, but not as much info. Okay, but if we draw it this way, it shows us something else. NaCl. Okay? Now you're wondering why that's so different. Yeah. If you're wondering why that's so different, we're going to do a different model here. Okay? We're going to do, let's see. Let's just do nitrogen and nitrogen. No, let's do oxygen. Oxygen's good. Okay? So we're just going to do O2. Okay? And so, oh, here we go. We're going to go O. And we go like this, and we go O, we go like this, and now your periodic table's staring at you. Okay? But if we do it with stick ball, we do this with an O in it, and we do this with an O in it. How many sticks do we use?
2.
Why do we use 2 sticks?
Is it the
There are
same
2
thing?
bonds.
Well, it's a double bond, okay? Are you guys starting to see how these are all the same? They're all a little bit different, but we use them for different representations because we use them when we're working with different components. If we're worried about electron transfer, we're going to do Lewis dot. If we're worried about showing someone how it's actually built, we're going to do stick ball. If we're worried about showing the bonds, we're going to use the triple, double, or single bonds to show people, okay? Does that make sense to you guys? Okay. All right, you guys did a good job today. We're going to save balancing equations
First.
for the Monday when you go back. Last.
Oh, so